Well, today's this topic of discussion is Coulomb's law. So you can write here. The electrostatic force appeared between two charged particles. Particle means point charge, okay? Because this should be valid for point charge only. And that is also at rest, okay, in space. Say this is one charged particle. So that is Q1. And at certain distance, there is another particle Q2. They have a separation, say R. So the force will be directly proportional to Q1 also, Q2 also, okay? If we have more charges, so obviously the force, whether it is repulsion or attraction, no problem. But value of force will be definitely more, okay? So it will be directly proportional to either charges, okay? You can say that F is directly proportional to Q1, like that. Then, if the separation is more, obviously the force will be less, okay? If the separation is more, the force between them will be less. But it is experimentally found that it depends upon the square of the distance, okay? Not actually directly, you can say that it is inversely proportional to R, but it is inversely proportional to square of the separation. It means F directly proportional to Q1 and Q2, product of Q1 and Q2, but inversely proportional to that one. Like that, okay? So if you equate both the things, then you are going to get F directly proportional to Q1, Q2 by R square. And remember, here Q1 is magnitude of charge, okay? So if it is minus 2 Coulomb also, so we'll take 2 only, okay? Because that plus minus will give the direction only, okay? Whether it is attractive or repulsive like that only, okay? But we are going to calculate the amount of force, okay? Amount of force. So in Coulomb's law, you do not put the charge with sign, okay? You always put it with magnitude. That's very important. So these two are called Coulomb's law, basically, okay? They are directly proportional to product of charges and inversely proportional to separation between them. So if we equate them, there will be a constant term. A constant term will appear. So that constant is nothing but small k. Okay. Here, small k is called Coulomb constant. Okay. Or it is actually basically it is a medium constant. Okay. So the two charges are placed in vacuum, or the two charges are placed in water or in some another medium. Okay. Depending upon that, the value of k will be different. Okay. So basically, it is a medium constant. Here, k is a proportionality constant called medium constant. Okay. You write all these things on the whatever appeared in the board. You should write. Okay. And do you know what is the value of k in vacuum? that Coulomb's constant in but that is actually medium constant, but if it is in vacuum, then the value of K is called Coulomb's constant also. Okay. And do you know this value actually? Value of K, that is nearly 9 into 10 to the power 9. Okay, I will just write it. So basically, K is a medium constant. For vacuum, the value of K is about 9 into 10 to the power 9. Okay, and this is also called Coulomb's constant. Okay, so value of Coulomb constant is 9 into 10 to the power 9. Nearly, it is actually 8.99 like that, but you can learn it 9.8. It be easier to learn because there is really same only. The value of K. Okay. But remember, it is in vacuum only. Okay. If it is in another medium, the value will change, and we'll discuss it later. Okay. How it changes. Do you have any doubt? It will give you the value of force. Okay. Value. If they are like charges, so definitely the force on this will be this one in this direction. Okay. If they are unlike charges, the force on this will be in this direction. So direction will be depend upon the sign of the charge, but it is basically it will give the magnitude of the force between two charges. Okay, two charges. So, do you have any doubts till now? I think no. Yes. Well, so here the Coulomb's constant K, that can also be written as, okay, that small k. Remember that is small k, not capital K. Coulomb's constant is symbolized with small k. And capital K will stand for, that is dielectric constant. That is another quantity. So here actually small k can also be written as 1 upon 4 pi epsilon naught. See, 1, 4 pi, but here a new term you are getting, that is called epsilon naught. Okay. That is actually called permittivity uh, in a medium. You see, say there are two persons, they are going to interact. Say they are two friends. So they are going to interact. But the medium is not allowing them to interact. Say there, we have a big wall in between the two friends. So can they interact? No? Yeah, say they are two enemies, okay? They are going to fight. But I put some medium in between them so that the medium does not allow them to fight. Means the medium, actually, whether the medium is giving the permission to interact or not, like this, okay? So this is one charge, positive charge. So this is a very big positive charge, and this is a very big negative charge. Obviously, the attraction between them also will be very big. No? But if I put some medium in between, and the medium is not allowing them to interact, so obviously, what will happen? They cannot. Okay, so by how much the medium interacts, allows to interact. Okay, that is understood by the quantity epsilon. Okay, epsilon. That is epsilon. And epsilon naught means it is for vacuum. Okay. For another medium, it will be simply epsilon. So what is epsilon or epsilon naught here? So it is basically permittivity of vacuum. Permittivity, you can say that the word coming from that permission only. Okay. So we do not require to discuss everything about this now. Okay, because we are going to discuss it later only. But for the time being, you should understand that it is simply it is like that only. Okay, whether the medium is allowing them to interact or not. Okay, because medium can also disturb, of course. No? So here epsilon naught is called permittivity. Okay, or that is. But it has also some value actually. Epsilon naught also have some value. The value of epsilon naught, actually you can say epsilon naught, value of epsilon naught is it is about 8.854 into 10 to the power minus 12. Okay, so if you put here and if you put the value of pi as 3.14, and multiply by 4 and take the reciprocal, you get this thing only. Okay. You can also learn this value if you want. You should learn this also. Permittivity of free space. So if I put K like that, so obviously Coulomb's equation will be like this only. F equal to what? F equal to K, yeah, 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay? Here we need to put Q1 and Q2 in magnitude. I have already told. But if we that one place two charges in another medium, okay, say in water, if I put the two charges, so what will happen? Okay, so we will discuss it later. Okay, first let us discuss about the properties of Coulomb's force. Okay, properties of Coulomb's force, that is also very important. So let us first discuss the properties of Coulomb's force. Is it like the other forces? Okay, the properties of electrostatic force also you can say. Okay, you can write it as properties of electrostatic force also. Okay. Very important. Huh? Even you can compare with the gravitational force also, because sometimes that is also asked in the examination. What is the difference between the one Coulomb's force and gravitational force? Like that. So first, it is a central force. So what does it mean? Central force means, say this is a point charge Q1, and say that is a point charge Q2. If you join the two particles, okay, this will be the line. So the force will be along this line only. If they are like charges, so they will repel in the same line, and if they are unlike charges, they will attract in the same line. Okay, so it is similar to the gravitational force only. Okay, gravitational force is also a central force. Well, okay. So I hope you understood the meaning of central force. Gravitational force is also central force. Coulomb force also central force. Then the second property is that quiz, the central force, you can write this also. This force acts along the line joining the two charged particles. Please write. Okay. Then the second property is it is conservative force. It is also same as that of that one. Okay. Gravitational force. Gravitational force is also conservative, and electrostatic force also conservative. Gravitational also central force, and electrostatic as central force. So conservative force means what? Means work done in a closed path is zero. Okay, means work done is path independent, or you can say that work done is that one. Work done in a closed loop is zero. Okay, potential energy defined in this conservative force. No? So this is a positive charge, and we take another positive charge from this point and take it and come back to this position only. So what is the work done by me? It will be zero only, because the force applied by this charge, na, it is just conservative only. Okay, work done in a closed loop is zero. And one more thing, say this is the point charge. I have taken this charge through this path to this point, and second time I have shifted this charge from this point to this point through a straight path or some other path. So in all the cases, work done will be same. Okay, means work done is path independent. Okay, and if it happens so, then the force is called conservative force, and the field is also called conservative field. Okay, we'll be discussing the field later. It is similar to gravitational force only. Right? In gravitation also it happens. Understood? Anything doubt till now? The
No, sir.
next point is it's a force of two particle system. It is also similar to that gravitational force only. Okay, a gravitational force also two particle system. Here, what does it mean actually? Say this is one particle, okay, and Q1, and this is say Q2, and the force between them is say 2 Newton. Okay, so if you place another Q3 charge nearby, then also the force between them will be 2 Newton only. Okay, but net force on it will be changed because this will also give some force. Initially, Q1 was giving this way and Q2 will give this way. So resultant force will be changed. But force between these two is independent of the presence of the third charge. Okay, that is called force of two particle system only. Okay. In case of actually nuclear force, na, that will be a multi-particle system. It is non-conservative. Okay, it is non-central. So nuclear force is like that. Okay? And frictional force is also non-conservative. So we'll have some differences also in different forces. But for the time being, whatever we have discussed now, all are same with the almost gravitational force. So I hope you understood what is the two particle force. You can write also this thing. It means the force between two charged particles will not change if a third charge is kept nearby. Okay. Well, it is noted down. Well, but net force on anyone may change, obviously, but force between two charged particles will not change. So this is the third property. Okay. Basically, it is a force of two particle system. That is the main highlighted point. And then let us discuss the fourth point. It is applicable point and stationary charges only. Okay, because you see, we need to know the distance between the two charged particles. No? So if it is not a particle, if it is a body, so how can you calculate the distance exactly? Na? Distance only is calculated between two point only. Na? That is why this formula, but the Coulomb's formula will be valid only for two particles, and that should also will be at rest. Na? If they are not at rest, another form of force appears between them actually. That is called magnetic force. That is why always we say that two particles should be at rest. Then only it will be allowed. Then next point, it obeys superposition principle. Superposition principle means, say this is one particle Q naught, and Q1 is giving a force, say in this direction, okay, and say Q2 is also giving, say this is F1, and Q2 is giving a force, say F2 in this direction. Similarly, say some another Q3 is there. Q3 is giving a force in this direction. So the net force on this particle, okay, that will be simply vector sum, not directly algebraic sum, vector sum of all the forces. That is called actually superposition principle, okay. Even you can write also what is superposition principle. Net force on a particle is vector sum of all the individual forces it experiences, okay. Because force is a vector quantity. So do you have any doubt till now?
No, sir.
Okay. Now, force between two particles in medium. Okay. Till now, we have discussed the force between two charged particles in vacuum. Okay. Say this is one particle, this is one particle. Say they repel each other. So, what is the force between them? It will be equal to 1 by 4 pi epsilon naught Q1 Q2 R square. Okay. But if they are in some medium, okay. So, what will happen? See, that is very important. When two charged particles are placed in a medium, the Coulombian force between them remains same as it was. Remember, the force between the two charges will not change at all. Say uh, the force between this Q1 and the Q2, okay? So that is equal to say 2 Newton in vacuum. But if I keep them in water, okay, then also the force between them, these two will remain same only. That will be 2 Newton only. But net force on this charge also will change, as well as net force on this charge also will change. Now a question may come to your mind, then why net? Means who are the charges additionally giving forces on this Q1? Because you see, apart from Q1 and Q2, no charges are seen in the medium. Na? So actually what will happen, you see, that is very important point to understand. Say a charge is placed in, a charge Q1 is placed in water, okay? Yeah, it's some other medium, okay? Then what will happen? Immediately, now when you place Q1, immediately what will happen? Some negative charge will be induced around it, okay? And then surrounding negative charge, some positive charge will be uh, that one induced around it. Then again surrounding positive charge, negative charge will be induced, okay. So it means in the vicinity, it means in the space, infinite number of charge layers will be created surrounding the Q1, and same thing will happen to Q2 also, because it's a medium, na, water. Say water is there, so water is, can be that one polarized like this. Na? A lot of charge distribution will be taking place in the space. Okay, there will be obviously non-uniform, but it will follow like this only. Okay, say this is Q2, so negative charge will be formed here, then positive charge will be formed, then negative charge, and it will go to infinity. Okay, it will go up to infinity. Now you see, initially when there was no medium, then Q1 was given a force only by Q2. But now what will happen? Q1 will be given by a force by all the charges in the vicinity. Q2 also will give, this positive charge also will give, this negative charge also will give, this positive charge also will give. Lot of infinite number of charges are there in different directions. Okay. So medium means collection of lot of charges only, infinite charges only. So all will give force. Okay. So hence the Q2, Q1 will get a net force, and Q2 also will get a net force. Okay. Initially Q1 was experiencing a force only given by Q2, and Q2 also experiencing a force only given by Q1. But now Q1 will experience lot of forces, not only given by Q2, but also given by all the charges in the vicinity, in the space. Okay. So that is why Q1 will get a net force. And the net force will be changed actually. Okay. Net force will become the net force will become 1 by 4 pi epsilon naught n epsilon r, or that can be written as k also, capital K also. In place of epsilon r, we can write k also, capital K also. So Q1, Q2, R square. Remember, this is not the force between Q1 and Q2. Okay. This is the force experienced by Q1 or Q2 or Q2. This is the value experienced by Q1 also as well as Q2 also. But force is given by not only the other charge, but also all the charges in the infinity. Okay. In the vicinity, in the environment, in the media. So when two charges, you please write down all these things. When two charged particles are placed in a medium, the Coulombian force between them will remain same as it was. Okay, between them will be remain same, but net will be changed. Okay, that I'm going to discuss. But the net force on either charged particle will become F is equal 1 by 4 pi epsilon naught k q1 q2 by r square. Even you can put it as f dash also. Okay, put it as f dash also. Okay, or you can write this expression. You can write f dash equal to 1 by 4 pi epsilon naught, and here you can write epsilon r epsilon r. Okay, epsilon r. What is the name of that epsilon r? I'll let you know. Q1 q2 by r square. So both are same also. Yeah, you can write directly k also, epsilon r also. No problem. So you please write both. So what will happen? This is actually, again I'm saying that k, epsilon r, these are medium dependent quantity. Okay. In water, k will be different. Er also will be different. Even value of ki and er is same only. Okay. So what is k here? K is called dielectric constant of the medium. Okay. Or you can write er is called relative permittivity. Relative permittivity. The medium. The value of relative permittivity or K will be given. Okay, will be given to you. For different medium, it will be different. So let me write for vacuum and for metal. Okay, you can write here for vacuum, yeah, space. Okay, for vacuum, K, capital K. Huh? This is capital K, not small k. Small k is the Coulomb's constant. Okay. Capital K or ER. Okay, that is equal to 1. For vacuum, it is 1. Okay. You should learn it. Huh? For conductor, means metal. Okay. For conductor, A or ER. Okay. That is infinity. That is infinity. Okay. That is very important. For metal, it is infinity. You see, if it is infinity, so something divided by infinity will be 0, na? So force will be 0. Okay. That is very important. Say this is a point charge. This is another point charge. And these two charges are kept in iron. So what is the force between them? Answer is 0. Okay, because that is infinity. Na? That is why k value or epsilon value is infinity. Na? That is why. And for other particles, okay, other medium which are not vacuum also, which are not media, conductor also, so value will be that one only, okay, in between them only, okay, in between infinity and 1 only. Okay. So you can write that part also. For any other medium, for any medium, K or ER, okay, is less than 1, sorry, less than infinity, but greater than 1, okay. So K value never be in decimal point, okay, never be less than 1, never be negative, okay, but it can be 1. If it is 1, it means vacuum. It can be infinity. If it is infinity, it will be metal. So understood or not up till now?
Yes, sir.
Okay. So let us practice 1-2 problems. Okay. So you please try to hit this problem. This problem based on today's class also, as well as the yesterday's class also. Okay. So try to solve this problem. I'm giving you about 2 minutes. Okay. So two charges are placed at 1 meter apart. Okay. So this is the charge. This is another charge. Okay. 1 meter. So 1 meter is fixed, and it is vacuum. So K value is fixed. So that charge should be minimum. Then force also will be minimum only, the smallest. So charge, minimum charge is nothing but the charge of electron only. Okay. Because we cannot get a charge which is less than the charge of electron. No? That is the quanta of charge actually. The charge cannot be less than this. You know. So that is why we have to put the value of means electron charge only for both the that one. So please go through it. Okay, Q1 and Q2 should be minimum only, and E is this. So F equal to Coulomb's constant because it is in vacuum. So it will be 9 into 10 to the 9 only. So Q1 is also electron charge. Q2 also. You cannot put 1. Okay, 1 Coulomb is a very big charge. Coulomb is not a small charge. It's a very big charge. So after solving, you can get this. Okay? Let us try another question. I hope you understood. No issue. A charge Q, small q, is placed at the center of the line joining two charges Q1 and Q2. Okay, joining two charges Q1 and Q2. Wait, we're getting 10 minus 38. It will be 28 minus 28. 2.304 into 10 minus 20. Some numerical mistakes I think you have done.
कि पावर 9 को भूल गई थी.
Okay, okay. So next question is a charge small q is placed at the center of the line joining the two charges of capital Q. Okay? So that is a capital Q charge. This is another capital Q charge. So there's positive only because nothing is said. Now the question is, we need to put small q in between them. Say I have put a charge in between them. So this is positive q, and that is also positive q, and in between them, small q is placed. Okay. Now question is, what should be the value of small q? The system should be in equilibrium. Okay? That is very important. System should be equilibrium. System should be equilibrium means all the charges should get F0 force. Okay. The force on all the charges. Okay. See, if you place it at the midpoint, so obviously the net force on it will be 0 only. So irrespective of the value of charge, you can say. Say this will repel it on. This will also repel it with the same amount only. So net force will be 0 only. But question is, this must also should be 0. Force on this charge also should be 0. So that capital Q will repel it. Okay. This is sure that one capital Q will repel the another. Okay. So it means that small q should be negative only, so that it attracts and net force on it becomes 0. Okay. This is the question. So I hope you should get 2 minutes. Okay. To solve this. Please try to solve it. Okay. Okay, I accept your answer, and I also think like that only. Say this is the positive charge Q. This is the positive charge Q. So the force given by plus Q and to that plus Q, it is say F1. Okay. And this is minus Q, and force given by this is say F2. And for net force become net force 0 on that capital Q. So F1 must be equal to F2 by magnitude. So F1 is what? That is K Q1 into Q2, Q1 into Q2 by R square. And for that one F2, it will be what? Q1 will be capital Q, and Q2 will be small q only, because the force between this. And you should not put minus sign here. Again, I am saying. and it will be R by 2, okay, R by 2. Why R by 2? Because if I take the separation between them as R, it should be R by 2 only because it is given in the question. The third charge is put exactly at the midpoint. So K will get cancelled, capital Q will get cancelled. So you are going to get Q equal to Q by 4. But remember, it is not the answer, okay? Answer should be minus Q by 4, okay? So because that must be negative, then only it will be attracted by this. No? So that is the magnitude only, okay? Because here always we put magnitude. No? So Q should be equal to minus Q by. That minus part is very important, okay? So try to hit this problem. Three surges, Q1 is 1 micro. Micro means that was minus 6. Q2 is equal to minus 2 microcoulomb. Q3 equal to 3 microcoulomb are placed on the vertices of an equilateral triangle of side 1 meter. Find the net electric force acting on charge Q1. Okay, I accept your answer. three charges. Q1 is positive here, okay? This is positive. Q2 is negative. Q3 again positive. Are placed on the vertices of an equilateral triangle of side 1 meter. Okay? Find the net force on Q1. Q1. So obviously this will repel it, okay? It will be in this direction. And value of F1 we can calculate as 9 into 10 to the power 9. Q1 is 1. 1 into 10 to the power minus 6. Okay. And Q2 is 2 into 10 to the power minus 6. Okay. Divided by 1 square. Okay, we should not write no. From that I can get it will be equal to 9 to 18. So that will be into 10 to the power 12 and 3. No? So minus 3. Or you can say 18 millinewton like that, okay? F1 is 18 millinewton like that you can write. Similarly, what will be the force given by this negative charge? Okay, it will be in this direction only. That will be F2. So F2 will be equal to again K into Q1 is 1 microcoulomb and Q3 is 3 microcoulomb. Divided by 1 square, so no need to put, so that will be 27 millinewton like that. But these two are making an angle 120 degree, okay? Because we know that this is equilateral triangle now. So all inside our angle should be 60 degrees. So as it is 60 degrees, so this angle will be 120 degree, which force between angle between the two forces are 120 degrees. So resultant force will be in this direction. So that will be equal to what? F equal to under root F1 square, F2 square, 2 into F1, F2 into cos 120 degree. So cos 120 degree equal to minus half only, okay? And you have to solve it, all these things, okay? After solving it, you are going to get the final answer. And I suppose it should be 2.38 into 10 to the power minus 2 Newton, like that. So calculation part can be done also using calculator also you can do it, no problem. But concept is very important, okay? That calculation part you can use calculator, no problem for the time being. But the concept part is very important. Well, one more question. More thing you should understand. Okay. Say this is Q1 and this is Q2, and that is in vacuum. Okay. So force on Q1 is what? F1 is say F. Okay. Now, if Q1 and Q2 are placed in a dielectric medium K, okay, then force on F1 will be what? F1 dash equal to F by K, okay? Because I have already told you na, that 1 by 4 pi epsilon naught, but in case of medium, it will be becoming 1 by 4 pi epsilon naught K. It is F by K only. Because in space, it becomes 1 by 4 pi epsilon naught Q1, Q2 by R square. But in that one, in medium, so it becomes like that only. So F dash by F equal to becomes K. Okay. So again, I am saying it is not the force between the two charges, okay, but it is the force on a charge. For this case, you can say it is between the two charges also because no other charge is available. But in the second case, actually, we cannot say like that because once you exert in a medium, so lot of charges produce in space, okay. So from that concept, I want to give you a question, and this should be the last question for the day, okay. And the question is, you please write down if the force between two point charges at a distance in vacuum is F naught. Find the force on either charge. Either means any one of the charge, okay? Either charge by the medium. That is a very important and it is a advanced level question, okay? So you have, but tricky, easy but tricky, okay? Find the force on either charge by the medium when the two charges are kept at the same distance in a medium of dielectric constant K. Okay. So you please try it. I will not give much time. Okay. But it is a tricky question. You try to visualize the situation and try to give the answer. Okay. And they are like charges, you imagine. Huh? If the force between 2 point like charges. Okay, let me discuss it. You see, it's a very interesting question. Okay, see, say this one is a positive charge. Say it is Q1, and this is another positive charge. Say it is Q2. Say Q2 repels Q1 with a force F0. Okay, that question. It means net force on Q1 is F0 only. Okay, but you see, when Q1 and Q2 are placed in a medium K, then of course the net force will become little bit smaller. Okay, and it will become F0 by K. Because you know that K value is always greater than 1 na, for any certain medium. So as the K value is greater than 1, so F0 by K value will be less than F0, you know. So initially force was little bit larger, but in the medium, but you understand that force between Q2 and Q1, it will be remaining same only. Because the force between any two charges does not depend upon the presence of the charges in the environment. Okay, so the force between this and this still remain F0 only, but net force on Q1 becomes F0 by K. So what does it mean? It means the remaining environment, means remaining charges, pull the Q1 in the right direction. Okay, then only it will become less, na? F0 will become F0 by K. So force by the dielectric will be, force by the medium will be what? Force by the medium on Q1. I'm just taking Q1 as sample only. You can discuss the same thing for Q2 also. Force by the medium on Q1. On Q1, okay, is, so that will be what? F0 minus F0 by K. That is the answer actually. You can write F0, you can take F0 common also. 1 minus 1 by K into F0 by K. Again, I am repeating, in vacuum, the force between them is F0. In medium also, force between them will be F0 only. But it is experiencing net force F0 by K. It means what? The rest of the medium is pulling it rightward with this much of force. Then only the resultant will become F0 by K. No? That is why. Okay? So this is the force F minus F0 by K. Or you can simply write 1 minus 1 by K into F0. It is the force given by the medium on Q1. Okay, and if I ask you, so what will be the direction of force on Q1 by the medium? So it will be in this direction, because then only the value will be reduced now. And for Q2, it will be in this direction. Means it will be, you can say that medium is attracting, okay, like that, because they were light charge na, initially. Okay. So I hope for this, I think today it is enough. Okay. So I'll do the practice numericals, and we'll discuss the one Coulomb's law in vector form also in the next class. Okay. So for that day, thank you. Okay. Bye bye.